Aurelia Falcicchio, speaking about qualitative phase analysis, theory and databases.
Thank you, Rosanna, and good morning, everybody. So first, I just thank the organizing and the scientific committee to invite me to speak about qualitative phase analysis, theory, and databases. So the outline of the talk, first, a little bit of introduction of powder X-ray diffraction for qualitative phase analysis. Of course, you already have here a lot, but still something new. And then qualitative phase analysis, the databases that are available to perform qualitative phase analysis, the program QualX2, of whom I'm a co-author, and I'm pretty sure that you already have downloaded the program and the database PowerCode. But if you have any problem, trouble, or just questions, ask me during the days. I will be here to answer to your questions. And in the afternoon, we will perform the qualitative phase analysis with some examples together. So X-ray powder diffraction is a really important technique because it has a lot of advantages and a numerous of application in science materials. Which is the aim of a qualitative phase analysis, is to identify a crystal phases of a polycrystalline mixture by using powder X-ray diffraction. So the use of these techniques, it's in industrial fields, for example, in pharmaceutics, if we want to perform a quality control of drugs and to check the manufacturing process, and also to check the impurity inside of a sample. And it has also a lot of uses in organic and metallurgic and organic chemistry, in mineralogy, in cultural heritage, and in material science in general. Which are the advantages for X-ray powder diffraction for qualitative analysis? So it's a technique really rapid and non-destructive. For rapid, I mean, it means more or less 1 day to get the data, and is not destructive technique because the sample usually can be recovered. There are, of course, some samples that are really sensitive for X-ray, but these are few cases. And also, it requires a small amount of the compound that we want to analyze, 10 or 15 milligrams, and it is simple to prepare the sample. You just have to reduce in powder your sample, and then you fill a capillary. You can choose and decide the dimension of the capillary that you want to use. And also, it's a fast measurement, and it's low cost. Low cost in terms of the... Okay. And the maintenance of the instrument is low cost. The system is really automatic, and the data are quite easily to interpret. And we can also perform a qualitative phase analysis, but also a quantitative. Of course, there are also some disadvantages. So, as I told before, can be samples that are really sensitive to X-ray. It requires standard reference for matching diffraction patterns. To acquire the machine, an X-ray diffractometer is quite expensive, and the amorphous material can give, as we already have here, a weak signal or no diffraction, and the overlap peaks can complicate the analysis, and in the end, we require good reference databases. The use for a qualitative phase analysis to determine the content of a crystalline samples, to measure and access the crystallite size, and to access preferred orientation and epitaxial growth, to estimate the purity of a sample, and to identify new materials or known materials by using X-ray powder diffraction with a known database. But what is a powder? As you already have heard, a perfect powder consists of an infinite number of small, randomly oriented crystallite. So we are talking about a dimension of 1.5 micrometer. And in this case, we can speak of an ideal powder. And the physical basis, I just repeat something that you already know. A powder diffraction obeys to the law physics of a single crystal diffraction, and at the location of the diffraction peaks is given by Bragg's law, and the intensity of diffraction peaks is proportional to square of structure factor amplitude. So here, that's an example of 3 phases. 3, I would say, crystalline phases or 2 crystalline phases. So each material has his own fingerprint powder diffraction pattern, so it has a unique X-ray powder pattern. So these are the 3 cases that Rosanna already have shown, the case of quartz, cristobalite, and glass. So as we know, the content of these phases is just silicon oxide. But if we have a look of the powder diffraction pattern, we have 3 really different cases. So we have the case of the quartz, the case of cristobalite, and the amorphous with this hill that is characteristic of amorphous compound. So if we have a mixture of 3 phases in the pattern, we will see the sum of each diffraction factor piece. So it's a way to say that each material has its own fingerprint that allows to understand what is inside of your sample. The phase identification could be a really powerful tool also to identify polymorph. Here are reported the 3 polymorph of titanium oxide. So you have brookite, anatase, and rutile, and the corresponding cells are reported. And also, the powder diffraction pattern are quite different each other. So if I have a sample that contains titanium oxide, by using qualitative phase analysis, I can detect which of them I have, or if I have one plus an impurity, one plus another one. So what we use on the experimental pattern when we perform a qualitative phase analysis. So the peak intensity contains the information on the composition, so the unit cell content. Instead, the peak position to theta and then the corresponding interplanar distances that we just get from the Bragg's law contain the information on the unit cell parameters. So the basic idea of the qualitative phase analysis is to reduce our diffraction pattern into a stick pattern. So we have a set of the high values, and the phase identification could be performed comparing the observed or calculated values corresponding to the known reference single-phase crystalline samples belonging to a database. So as here, we have a powder diffraction pattern that is reduced in an experimental stick pattern. So the diffraction peak lists are best reported using DHKL and the relative rather than to theta and absolute intensity, because the peak position depends on the instrumental characteristics, such as the wavelength, and the peak position as DHKL as intrinsic, instrument independent. So the absolute intensity is the number of X-ray observed in a given peak can vary due to the instrumental and experimental parameters that we use. Instead, relative intensity should be independent. So to calculate relative intensity, divided the absolute intensity of every peak by absolute intensity of the most intense peak. So peaks area are much more reliable than peak haze when measure intensity. But the success of a qualitative analysis depends on some parameters. So the quality of the data and, of course, the accuracy of the experimentally high values. So usually when we think to a qualitative phase analysis, we think that it's quite easy to perform a qualitative phase analysis. But today, still nowadays, to perform a correct qualitative phase analysis when we have a mixture and a complicated powder diffraction pattern is still a challenge. As here we will see, we have a huge number of problems that can be affect our pattern. This is the case of the overlap reflection when we have two or more than two peaks under only one peak. Or another problem is the preferred orientation. So a sample with a preferred orientation has a lot of crystallized that are preferred oriented. This makes, of course, an error when we calculate the intensity because much peaks are more intense. Another problem is the amorphous contribution. So when we have the presence of the amorphous, it's quite difficult to understand if under that hill we have also one peak that contribute to have a phase inside the sample. And also the wrong contribution of the background. When we calculate the background, we can have also we can make an error. So due to all these problems connected with powder diffraction, we advise when we have a complex mixture to add other additional techniques just to access what we have obtained with a qualitative phase analysis. So we can also add data from X-ray, fluorescence, Raman, IR, SEM, and so on. Another aspect for the success of the qualitative analysis is the efficiency of the phase identification method. So this is a method that first consists of assert and satisfying a guiding criterion. So we can have more methods. So the Hannawald method is based on the 3 strongest lines. The Fink method is based on the first 8 lines with the largest d-value, or alphabetic method, and so on. And also, when we have the powder diffraction pattern reduced in the high values, then we have to match these high values with the one belonging to a databases. So we have to match. And in the end, we have to access the identification and to try to access the reliability that is given via a figurate merit. So to access a phase is a combination of experience of the researcher that is performing the qualitative phase analysis, the already known information about the sample. For example, I know that it's an inorganic sample, so I have to exclude what is organic inside, for example. And then, of course, I have to give the right importance to the figurate merit. That is a measure of that phase is inside the sample that I'm analyzing. So the new methods for qualitative analysis are one of these is the one proposed by Gilmore, and it is based on a statistical approach for a full pattern matching and on clustering methods able to group similar patterns into clusters and to recognize these similar samples, such as the polymorph. And in the end, it's really important the completeness of the reference databases that I'm using and the accuracy of the high values of the reference database of a known crystalline phases. So here there's a list coming from the web page of UCR, a list of databases that are the most used today, and one of the most used is a commercial available database. It is a PDF that is continuous update, and you will hear a lot during these days. And among the freely available database, we have the American Mineralogist Crystal Structure Database that is belonging to mineral compounds. And another one belonged to free available database is the COD, Crystallography Open Database, that contains a huge number of entries in the code, and their number is continuously growing. So, computer program for qualitative phase analysis, there are some that are reported also on this web page, and an example of search match software is Qualix2. Qualix2 is a program that is developed at the Institute of Crystallography and is available free of charge for no-profit institution, as Cinzia already have told you. So the technical details of the programs, it runs in Windows operating system and is written in Fortran and C++, and the output is in HTML format. So the file that can import Qualix are ASCII file. We have just 2 columns in free format, or 2 steps and maximum 2 values in the first row, followed free format comes in the next lines. But during this afternoon, we will see carefully which kind of data can read Qualix and how works the program. So applies the most widely used approach for qualitative analysis. So reduce the experimental powder diffraction pattern in a stick pattern, the high values, as here is reported. Then it query to a database of stick patterns of known crystalline compounds to search for a database patterns, best matching the experimental one, and then supplying a list of a plausible phases that could be inside it, ranked according to a figure of merit. So which are the main features of the program? It is characterized of a high level of automatism and user-friendly graphic interface. Of course, it's really easy to use Qualix, but it is recommendable to don't use Qualix just clicking the program, but with a rationable behavior. So just know what are you doing. There are some steps that are always the same, but the researcher can decide the background, can decide the peaks, and can decide the database, or to apply some restraints when he is performing a research. It can estimate a background in an automatic way, or just choosing the peaks and remove it. It can locate the peaks and derive the high values. It can search by using also PDF, and it is possible to use some restraints. If already I know some information about the sample, I can use it. And also it can perform a semi-quantitative analysis. But in case of complex mixture or mixture of more than 4, 5, 6 phases, the semi-quantitative analysis could be affected by an error. And also, Qualix has the possibility of querying to a POW code database. So what is POW code? Recently, what has been happened that some private company have developed software for X-ray instrumentation, have distributed freely available databases which can be read by quantitative analysis commercial software. So just on this, POW code is a database for qualitative analysis consisting of a collection of entries whose main crystallographic information are generated by using EXPO program, that is a program for structured solution developed also this at the Institute of Crystallography, and the zip files are downloaded, and then what happened that we have entry of where each POCode entry is identified by a 7-digit number associated to the corresponding file present in code database. So the qualitative analysis consists on some steps. So first, reduce the pattern and the high values. Then we can decide to remove the background, then a quick search, and a search in a database. So what do the program is to match with respect to different diffraction patterns of known compounds that belong to a database, and then they are ranked according to a figured merit. You can also perform the research by using some restraints. A window like this, when you decide to apply the restraints after the research, is a window like this. And you can decide if you already have information about the composition of the chemical name of the entries, the number of the entries that you are using, the symmetry. And you can load just the cards, unload and merge the cards with your search, or only search with restraints. So the success by using Qualix depends on the quality of data, on the adopted phase identification method, on the accuracy of the high values, and the completeness of the reference databases. Some final remarks. The success depends strongly on the experimental diffraction data and the completeness of the database that we use. But of course, sometimes happens that we have to use additional techniques to be sure on the results of the qualitative analysis. And Qualix is a software freely available and able to inquire a freely available database. So in the end, I want to thank all my colleagues that are co-author of Qualix, and here are reported, and all of you for the kind attention.